Rate of change in slope. What is slope and how is it determined? Now, let's start out by drawing some rectangles on a coordinate plane in the first quadrant. We're going to take a look at a rectangle here that measures 4 high by 2 wide. We have a blue one here that measures 6 high by 3 wide. A yellow one that is 8 high by 4 wide. Then we'll have a purple one here that is 10 high by 5 wide. A brown rectangle that is 12 high by 6 wide. And finally, a red rectangle that is 14 high by 7 wide when we measure boxes. Now, one thing you will notice is that the line that we have that's going through the corner of every single rectangle separates that rectangle into 2 triangles. So we can see that there's a triangle on each side of the line, and what we're going to do is deal with that triangle. That triangle is going to help us to define this rate of change. And what's interesting is that the triangle in math represents change. So we want to keep that aware so that we're looking at change, and this triangle is going to help us define that change. Well, now looking at these triangles, let's write down what the change was. What was that change in y values and the change in x values? So we'll start with the green one. We can see that it measures 4 high. So we have a change of 4 boxes. The width is a change of 2, so we have 2 boxes. And we can do this for every single one of these. The blue one would be 6 to 3. The yellow would be 8 to 4. The purple would be 10 to 5. The brown would be 12 to 6. And the red would be 14 to 7. Now, one of the things that is very interesting about all of these fractions is that every single one of these reduces down to 2 over 1. It didn't matter how big that rectangle was. When we took the measurements or the change in the y and the change in the x's, what we did is we found out that it reduced to be exactly the same thing. Now, these were all based out of the origin over in the corner here. What happens if we look at a triangle that's more in the middle, one that we've built here? So let's take a look at what that change is. We can see in the y, which is going up and down, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and a change in the x direction, 1, 2, 3, 4, 5. And again, this will reduce down to 2 over 1. We can find smaller triangles and similar ones here as well. From this point to this point, we can see it's 2 boxes by 1 box, which verifies this 2 over 1. So it doesn't matter where we build our triangle, which 2 points we choose to build it from, we're always going to reduce down to the same rate of change, which proves that slope is a constant, that rate of change is a constant. So when we look at rate of change, we know it means the same as a ratio of change or a fraction of change. So we need to know that the words rate, ratio, and fraction all mean the same thing. We're looking for a number that's a fraction that will show us the change. What are the changes? And when we take a look at the changes, what values are changing on those graphs? Well, the values that are changing on the graphs are the x and the y values. That's what's changing, and we're recording those changes. When we take a look at the change in y divided by the change in x, we're basically going to take whatever the y's are, those values, and subtract them from each other, and do the same thing with the x's and subtract those from each other. This is called slope, and is used and defined by the letter m. If you think about it in terms of a constant, sometimes we have seen it this way. This k and this m mean exactly the same thing, because slope is a constant, and we just saw it a second ago by using the triangles. We can use the same triangles over and over to get us a constant slope. Now, let's take a look about direction, because direction is important. I have my friend Red here to help us. Now, if we were going upstairs, Red would be walking up here and she would be walking down here. But if she was walking in the other direction, and let me flip her around here a second. What if she's walking this way? Well, all of a sudden, she's walking up the hill, isn't she? So we have to come to a decision which way we need to look at up and down and things like that. Well, we know when we read from left to right. So we're going to do that the same thing here with our graphs. When we're going uphill, or we're going left to right, going uphill like we are going up some stairs, we are going to say that this is a positive slope. When we're going downhill, or as we go walking along, we start to go down the plane here, or down the line, we're going to say that we have a negative slope. It's important to remember several things. Remember, slope is a constant. Slope is represented by a number. So far we know we can have a positive number or a negative number, and either way is going to be displayed as a fraction. But there are other alternatives besides positive numbers and negative numbers. Let's take a look at that. Now, instead of walking uphill and downhill, there's a possibility of just walking along flatly. When we talk about that, we're talking about a zero slope, because if it's not positive, it's not negative, it's zero. Now, we said that everything is represented by a number, and we know that zero is a number, but we also said that slope can be represented by a fraction. So when we have zero in a fraction, it's always going to be in the numerator. Doesn't matter what number is in the denominator, because we know that we can multiply these two numbers together to get this number. So 3 times 0 gives us 0. So we can prove that when the zero's in the numerator, that fraction reduces down to 0, therefore we have a zero slope. Now what happens when the zero's in the denominator instead? Well, here we have a line that is going up and down, and this line is going to be a little bit different. We've already talked about positive numbers, negative numbers, and zero, but then we have what we call undefined numbers. So this is an undefined slope. It has not yet been determined what that value is, and at this stage of the game, it is impossible. Now, when we come to think of that as far as making a fraction, the zero will be in the denominator and a number in the numerator, because if you think about that, what number would you multiply 0 by to get 2? At this point, it's undefined. We don't know. So when we see a line that goes up and down, we know that it is undefined, or if a 0 is in the denominator, it also tells us that it's undefined. So let's put some things together here, and let's put some points on the plane so we can practice finding some slopes. So first, let's plot the point 2, 4. 1, 2, and up 4. And we're going to label that point A. We're going to go to point B, which is 6 over and 6 up, and we'll label that point B. And then we'll have point C here. And then what I want you to do, and forgive me if my lines right now are not perfect, but they will be in a second. We're going to draw ourselves a triangle. We're going to connect these lines, and we're going to talk about these lines in terms of slope. And we'll take a look at each one of them, decide what kind of slope we have, and then prove it. So when we first off, we take a look at the line AB. Now you'll notice there's no directional line on top of this. That means we're just putting it in alphabetical order. So when we take a look at the line A to B, which would be these 2 points here, we know if Red, our friend, came walking along, as she came over from left to right, she'd be walking up. So we'd end up with a positive slope. So let's use that slope formula, which is the changes in the y's divided by the changes in the x's. And let's plot numbers in here and to determine what the value would be. And we need to remember that the formula says we're subtracting the y values, so I can pretty much set this up before we start. I want to take these numbers 4 and 6, those are the y values, and I'm going to put them in the numerator. I'm going to save the numbers 2 and 6 and put them in the denominator. Before we continue, I do want to point out it is important that pairs of numbers be over each other. The 4 and 2 go together, they need to be in the first spot. The 6's go together, they need to be in the same spot. They need to be over each other. Make sure you don't switch them around or you get a totally different number. Well, 4 take away 6 is negative 2. 2 take away 6 is negative 4. We know a negative divided by a negative is a positive, and if we reduce this down, 2 divided by 4 becomes 1/2. So we know just by doing the math or plugging in the numbers into the formula that that does work. But now let's take a look at it another way. Let me erase this here. And what we're going to do is we're going to try counting rise over run. So remember, rise is going up and down, and we're going to go from this point to this point. So from one place to another. So here we notice that we're going to go up 2 and 1, 2, 3, 4 over 4. And because we're going uphill, again, 2 over 4 stays positive, up 2 over 4. The change in the y and the change in the x, rise over run. And when we simplify that down, we get 1/2. And so since we got the same answer, whether we're counting or using the formula, we see it works. Okay, we're going to do this a couple more times. Let's try it now with the line BC. So for BC, even though I'm putting it in alphabetical order, we're really walking along this way and going up. So we know that we must have a positive slope when we're on this side. So going up here to positive, we're going to do it again. We're going to start off with the slope formula. We're going to take the y's and put them in the numerator. So for us here, the y's are 6 and 0. So 6 take away 0, and then 6 take away 4 will be in the denominator. We go and simplify that. 6 take away 0 is 6. 6 take away 4 is 2. Simplify down even further, we get 3 divided by 1. Now what we're going to do is we're going to count up and over and see if that is truly the right numbers. So here we go. We're going to go from this point to this point. We notice that it's 2 boxes over and 1, 2, 3, 4, 5, 6 boxes down. So there we see the same thing, the rise of 6, the run of 2. And it reduces down to 3 over 1. And we can see that's really true because this could be 3 over 1, and there's another triangle. And we just talked about how similar triangles do prove that rate is constant. So that 6 divided by 2 does reduce down to 3 divided by 1. And again, proves our point that slope is constant and that we know that this answer is right mathematically. Let's do it one more time. Let's find the measurement of AC. And when we're looking at AC, we're looking from this point here to this point there. And we know it's going downhill, so we know we're going to end up with a negative slope. So we want to make sure our number's negative. Y minus Y, X minus X. And we're going to drop the right numbers in, so we need the 4 and the 0. You'll notice that I circle the Y's. I do that on purpose so that I make sure my eye grabs the right numbers. It's a great little practice to get into. Then I just have to check to make sure that the numbers that are paired together are right over each other. 2 and 4, 4 and 0. Now I want to do the math. 4 take away 0 is 4. 2 take away 4 is negative 2. I'm going to reduce that down, and that becomes a negative fraction of 2 over 1. Well, let's do the visual here and see if it works out. We have 1, 2, 3, 4 boxes down and 2 boxes over. And again, 4 boxes down, 2 boxes over, reduces down to negative 2 over 1. And you'll notice that up here I put the negative at the top. It doesn't matter if it's on the top, on the bottom, out to the side. As long as there's one negative sign, it shows that it's a negative fraction. Hopefully you've learned a lot about rate of change and slope by watching this.